Welcome to Maths for You YouTube channel. Past question on complex algebra. Let z equal x plus iy, where x, y are elements of real numbers. Define the modulus z and the conjugate z bar, call the notation, conjugate of z. Then show that the first part, z times its conjugate equal the modulus z squared. So let's deal with the first part. And the define means zx plus iy. Of course, the modulus is standard. The basic knowledge is the square root of real part squared plus imaginary part squared. That gives us the modulus. And then the conjugate is simply change the sign in the middle. So x plus iy is z. So the conjugate of z is x minus iy. So that we have defined it. Now the first part, z time z bar or conjugate. So z is x plus iy, z bar is x minus iy, or conjugate is x minus iy. We need to prove z times z bar equal the modulus z squared. So if we could take the left hand side equals z times z bar, z is x plus iy times x minus iy. Remove the brackets. X times x squared, x times minus iy is minus ixy. Then plus iy times x, I times xy. Then minus I times I squared, y squared. So the minus ixy plus ixy will be cancelled out. What we left is x squared minus I squared, y squared. I squared is, we know, is minus 1. Therefore, the minus becomes plus. What the answer is x squared plus y squared. So that is x squared plus y squared. That is obviously modulus squared. So just we wanted to take this the right hand side. Just proving it. Modulus z is square root of x squared plus y squared. Z squared is x squared plus y squared and x squared plus y squared. That is equal right hand side. So left hand side equal right hand side. Therefore, z times z bar equal modulus z squared. That first one. Second question, z plus z bar, so z plus its conjugate equal 2 times the real of z. And again, z minus z bar equal 2 times imaginary of z. 2i says, or let's see that, 2i imaginary of z. Obviously, the I doesn't make any sense. So 2 imaginary z, 2 times imaginary of z. Okay, z equal x plus iy, z bar equal x minus iy. Then if you add them together, the imaginary part cancelled out, minus and plus will cancel out. So what we have is only 2x. That is the real 2 times the real part of z. The 2 times real part of this is 2 times real part of z. That's what we need to prove. 2 times real part of z. And the next one, z minus z bar, just x plus iy minus x minus iy. Remove the bracket, x plus iy minus x plus iy. So x cancelled out. What we left with, the 2y. So that this one is 2 times imaginary part of z. So in the question, 2 are imaginary part of z. That's not correct. So 2 times imaginary part of z. But when you say imaginary, so just I involved. So you don't need that. Right. Let's look at further questions. Let's z not equal 1 and w 1 plus z or 1 minus z. Show that the real part of w equal 1 minus the modulus z squared divided by 1 minus z, the modulus of 1 minus z squared, and the imaginary part of y equal to imaginary part of z divided by 1 minus z squared. This is correct. 2 imaginary part of z. That's how it should be. The first part. Anyway. Okay. Z is x plus iy. The term and w equal 1 plus z or 1 minus z. It's the reason why z not equal 1 because of this 1 minus z the denominator. It will make it meaningless w. So that is why they said so. Okay. W equal 1 plus z, that's 1 plus x plus iy divided by 1 minus z. So 1 minus x plus iy. If we could simplify it, the denominator 1 plus x plus iy, the denominator, so if you put it this way, the denominator 1 minus x minus iy. We have two complex, numerator complex and the denominator complex. So in order to deal with this one, we have to multiply top and bottom, or numerator and denominator, with the conjugate of the denominator. The conjugate of denominator is 1 minus x plus iy. So we are multiplying top and bottom with that. So if you do that, the top one will be x plus 1 plus iy, x plus 1 or 1 plus x plus iy, and the other one is 1 minus x plus iy divided by, and it's straightforward, a minus b, a plus b here. So that is a squared minus b squared. So 1 minus x squared minus I squared y squared. So simplify the denominator. So multiply by 1 plus x, the real part. So 1 plus x times 1 minus x. So 1 plus x, 1 minus x. Then 1 plus x times iy. So 1 plus x iy. And then multiply by iy times 1 minus x, iy times 1 minus x. Then I squared, y squared. And the denominator is 1 minus x squared, the I squared equal minus 1. Therefore, minus become plus y squared. The top one, if you look at it, 1 plus x times 1 minus x, a plus b times a minus b, so a squared, b squared. So 1 squared minus x squared, so 1 squared is 1, so 1 minus x squared. Then if you remove that, if you take that iy as common, then 1 plus x, then 1 minus x. So 1 plus x plus 1 minus x. Then the other one, what we left is I squared minus 1, of course. So minus y squared, this one. Right, and the bottom one is 1 minus x squared plus y squared. Okay, so if you could further, and again, of course, the plus x and minus x cancel out. Right, if that's cursor, could simplify it further. 1 minus x squared plus iy is only 2 left, so 2iy, and then minus y squared divided by 1 minus x squared plus y squared. I just would like to separate it because of this complex number, just separated real and complex part. So the if I take 1 minus x squared and the y squared as a number, so 1 minus x squared minus y squared divided by the denominator 1 minus x squared plus y squared, and again the 2yi, so I times 2y over 1 minus x squared plus y squared. So this is the imaginary part, so this is w. So we have simplified w in the form of a complex. So what we need to prove, again, this is a real part, this is the imaginary part. We need to prove 1 minus z squared, 1 minus z squared. Okay. So that's a question. Let me see. So we need to prove that real part of w is equal to that. So what we are doing, we're just dealing with this second part, also the right hand side. Here, this is the right hand side. Okay. Right hand side of the equation which we need to prove. Okay, 1 minus z, the modulus z squared divided by 1 minus z, the modulus of 1 minus z squared. So we know just 1 is 1. The modulus z is x squared plus y squared. Modulus z squared is x squared plus y squared. So that's the first part, the nominator. And 1 minus squared. So it's 1 minus z is 1 minus z equal 1 minus x minus I y. 1 minus x minus I y, yes. 1 minus x minus I y. So what I'm doing, 1 minus x minus I y, so the modulus of this, modulus of 1 minus z equal square root of 1 minus x squared plus y squared. That is exactly what we did here. So the squared, so 1 minus z, the modulus of 1 minus z squared is this. So we have simplified 1 minus x squared minus y squared over 1 minus x squared plus y squared. If you look at the real part of w, it's same. This 1 minus x squared minus y squared was, and the bottom part. So that is real part of w. That's real part of w. Again, see what's this 2 times imaginary part of z divided by 1 minus z squared. 1 minus z squared, we just said it here already, that this one. So 1 minus x squared plus y squared, so straightforward from the first part. And the imaginary part here, 2 times imaginary part of z is 2y. So the 2y over that. Now, if you look at the w here, I times 2y over 1 minus x squared plus y squared. So therefore, the 2 imaginary part of z divided by 1 minus z, modulus of 1 minus z squared is 2 times imaginary part of w. That's done. Okay, let's do it. The last part, show further that if z equal cos alpha plus sine alpha, I sine alpha, then w equal I cot alpha by 2. I cot alpha by 2. All right, it's a bit of trigonometry. Right, that is given that cos alpha plus I sine alpha, and w equal, we know that 1 plus z or 1 minus z, this is we've been given. So simply substitute that cos and sine for z. So 1 plus cos alpha plus I sine alpha, 1 minus, I just separated, 1 minus cos alpha minus I sine alpha. Again, is the denominator is complex. To remove that, and make that top and bottom, or multiply top and bottom by its conjugate. So its conjugate is 1 minus cos alpha plus I sin alpha. So so the top part is 1 plus cos alpha plus I sin alpha, and we are multiplying by 1 minus cos alpha plus I sin alpha, and 1 minus cos alpha, the denominator, minus sin alpha, I sin alpha, and again we are multiplying by 1 minus cos alpha plus I sin alpha. So the denominator is simplified. So cos 1 plus cos alpha first, 1 plus cos alpha time 1 minus cos alpha, then 1 plus cos alpha time I sin alpha. So I sin alpha top 1 plus cos alpha to, okay, 1 plus cos alpha here, and then I sin alpha time 1 minus cos alpha, that this one, and I sin alpha term I sin alpha, I squared sin alpha, sin squared alpha, I squared sin squared alpha. The bottom one is a minus b, a plus b. So therefore a squared minus b squared. So 1 minus cos alpha squared minus I squared sin squared alpha. Right, there's further simplification. If you look at it, 1 plus cos alpha and then 1 minus cos alpha, a plus b, a minus b, therefore a squared, b squared. So we can write a squared is 1 squared is 1 minus cos squared alpha. So that part is 1 minus cos squared alpha. Then we can take I sin alpha common. What we left with is 1 minus cos alpha plus 1 plus cos alpha inside the bracket. And then I squared equal minus 1. If you look at it, I squared sin squared alpha plus I squared sin squared alpha become just sin squared alpha. And the denominator, if we could expand it, 1 plus cos alpha squared, that is 1 minus 2 cos alpha cos squared alpha, just expansion of the square and linear function to quadratic function. So 1 minus 2 cos alpha plus cos squared alpha. And then I squared is plus minus 1, therefore plus just sin squared. Right. Cos squared alpha, we know that sin squared alpha, that's simply cos squared alpha equal 1 minus cos squared alpha equal sin squared alpha. So that's what we did. So sin squared alpha minus these cos alpha cancelled out, plus cos alpha minus cos alpha cancelled out. We only got 1 minus sin squared alpha. Sorry, no, we only got 2. So I times 2 sin alpha. Then I got this minus sin squared alpha here. So sin squared alpha cancelled out, 2i sin alpha left, and the bottom one, of course, cos squared alpha sin squared alpha is 1, cos squared alpha sin squared alpha 1, that is equal 1. So here I put 1 here. So 1 minus 2 cos alpha is plus 1. So what we left with, everything gone, 2i sin alpha over 2 times 1 minus cos, it's 1 minus cos alpha, yes, 1 and 1, 2, 2 minus 2 cos alpha. So if you take 2 out, 1 minus cos alpha inside, and this 2 cancelled out. Now we have we have I sin alpha divided by 1 minus cos alpha. What we know, this is students should know, this sin 2a equal 2 sin a cos a. Here I just wanted to write sin alpha equal 2 sine half of that alpha by 2 cos alpha by 2. That is exactly what I did. So instead of sine alpha, I just put, keep the I there, and I put 2 sine alpha by 2 cos alpha by 2. And again, the denominator is cos 2a equal 1 minus 2 sine squared a. So here we have cos alpha. I put 1 minus 2 sine squared alpha over 2. That's what I put it here. So it's I times 2 sine alpha by 2 cos alpha by 2 denominator. Then 1 is 1. And instead of cos alpha, I put 1 minus 2 sine squared alpha by 2. That is alpha by 2. Then the first part, I is still there, and we have 1 minus 1, and the minus times minus, it will be plus 2 sine alpha squared, that is by 2, sine alpha squared by 2. If you look at it, 2 cancelled out, and sine the square alpha by 2 and sine alpha on the denominator, that's one of them cancelled out. So all I have here is I times cos alpha by 2 divided by sine alpha by 2. Cos alpha by 2, or cos over sine, is cot. So I cot alpha by 2. Anything more? Yes, it's I cot alpha by 2. Thank you. Please subscribe the channel, share the contents with your friends and other fellow students. Yeah, it's just an additional info. From 1st of Feb, I'll be uploading past questions and answers for UK GCSE and Australian Year 10, Sri Lankan GCE O level. Thank you.